Okay, hello, a very good day to you. So my name is Chia Jin Yong from the BEI Group Melaka 1 UTEM. So this is our assignment, Power System Technology. The subject code is BEI 2383. So our topic is power factor regulation. So our lecturer is Dr. Zikri Abadi Baharuddin. So next. So before that, I want to introduce the power factor. So the power factor is a critical aspect of electrical system that directly impact efficiency and energy consumption. Second, achieving a high power factor is essential to optimize the utilization of electrical power and reduce the energy cost. And the last, the power factor regulator, or we can call it PFR, is a key device used in electrical engineering to actively manage and improve power factor. Next. So, what is the power factor regulator, or call it PFR? So, a force vector regulator is an advanced electronic device designed to control and regulate the power factor of an electrical system. Its primary function is to ensure that the relationship between voltage and current in the system is as close to unity, approximately 1 as possible. PFR actively adjusts the power factor to minimize reactive power and maximize the real power, resulting in improve the energy efficiency. So this is the introduction of the power factor regulator. So next I will pass to my fellows, Mr. Shamil, to continue it. Thank you.
Okay, thank you to Mr. Chia. Okay, I would like to continue the slide. So this is a type of power factor regulator. The power factor regulator PFRs come in various types, each designed to address specific requirements and conditions in electrical systems. The two primary categories of PRFs are passive and active regulators. Okay, here is show as a active power factor regulators. First, static VAR compensator SVC. SVC are dynamic PFR that use solid state device, usually terrators or insulates base bipolar transistor to provide precise control of reactive power. They can both generate and absorb reactive power as needed, making them suitable for application with highly fluctuating loads. Second, active harmonic filters. The AHF are specialized active PFR that's not only correct power factor but also mitigates harmonic in the electrical systems. They use also in power electronics to dynamically inject or absorb both reactive power and harmonic currents. And the third, active power factor corrections controller. FP APFC controller are integrated into electrical system and use power electronic to continuously monitor the power factor and control the reactive components such as capacitor and inductors. Apparently, they are available to a wide range of loads conditions. Okay, that's on my part. I pass to my friend.
Thank you to my friend Shamil. Now I will continue to passive power factor regulators. The first one is fixed capacitor. These are the simplest type of PFRs. Fixed capacitors are connected in parallel to load to provide reactive power compensation. They are set to specific capacitance value and do not adjust automatically. They are suitable for load with relatively constant power factor need. Fixed inductors. Fixed inductors can be used to introduce inductive reactive power compensation in parallel with the load. Like fixed capacitor, they are set to specific value and do not adjust diametrically. Next. So this type of load definition. So the first one is resistive load. Any heating load that consume active or real power phase angle equal to 0. For the example, for resistive load is incandescent light, toasters, water heater, oven, coffee maker, etc. And the second one is inductive load. The load that utilize reactive power to create magnetic field that rotate the motor. All inductive load require two kinds of power to operate. Active power heavy to produce the motive force and reactive power heavy AR to energize the magnetic field as a lagging power factor. For the example, inductive motor, VFD, vacuum cleaners, washing machine, air conditioner, etc. And the last one is capacitive load. The load that doesn't exist in standalone form like resistive light or inductive motors has a leading power factor. For the example is capacitor bank, motor starting capacitor, and generators. Now I will pass to the next slide to Farah.
All right, thank you, Mr. No, my groupmate and classmate. I am Muhammad Amirul Amin bin Razali. I will explain you example of power factor regulator connection with the capacitor bank. As we can see from the diagram here, we have a 4 capacitor that different parameter value. So the first capacitor is 5 kVR, and the second capacitor has a value that 10 kVR, and the third capacitor has same value 10 kVR, and the fourth capacitor, that value is 20 kVR. So we can see we have a connector to each capacitor, and we have a protection, circuit breaker protection, and then the connection will directly to the power factor meter. Next, how a power factor regulator works. A power factor regulator, PFR, works by actively controlling the power factor in the electrical system, typically by adjusting the phase relationship between voltage and current. It accomplishes this by adding or subtracting reactive component, such as capacitance or inductance, to the electrical circuit. This is the triangle for electrical power in system. Is divided into 3. Firstly, the active power. This is the power needed to useful work, such as turning a lathe machine, providing a light, or pumping water. This active power expressed in watts or in kilowatts. Next is reactive power, Q. Reactive power is a measure of the stored energy reflected in the source, which does not do any useful work. Reactive power expressed in var or kilovar. The last is apparent power. Apparent power is the vector sum of active and reactive power. Usually, apparent power is expressed in the volt ampere or kilowatt ampere. Next, I will pass this next slide to the Farah.
Alright, thank you, Mr. Amir Amin. Okay, I am Nur Faraida Yuwente Braza. Okay, so this is benefits of power factor correction. Okay, first, improve energy efficiency. One of the primary benefit of power factor correction is increased energy efficiency. By improving the power factor, you reduce the amount of reactive power in the system, which reduce the overall power consumption for a given level of useful work, real power. Okay, the second one is reduce energy cost. Okay, power factor correction leads to reduced energy consumption, resulting in lower electricity bill. Many utilities charge commercial and industrial customer based on both real power, kilowatt, and reactive power, kilovolt, ampere, ampere, ampere reactive or kVAR. A higher power factor means you pay for less reactive power. Okay, so next. Okay, the third one is minimize voltage drop and flickers. Maintaining a high power factor helps stabilize the voltage in the electrical system. This reduces voltage drop and fluctuation, which can cause equipment malfunction and flickering light, especially in industrial and commercial setting. Okay, the fourth is improve power quality. Power factor correction can enhance overall power quality by reducing harmonic distortion and voltage waveform distortion in the electrical system. Okay, so next I will pass to Mr. Fauzi for the next slide. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Saya Fauzi bin Ahmad dari Kumpulan Melaka 1. My part is conclusion power factor regulator. Conclusion. In the summary, is it imperative to cooperate a capacitor bank in any project design and dimension? This is essential not only to shield consumer from penalty imposed by the authority TMB, but also to boost the available real power. Consequently, this enhancement permit to include of additional load to project transformer, resulting in reduce the voltage fluctuate, lower in electricity expense, and decrease heat generation into the system cable, switchgear, transformer, and alternator. The power factor correction provide economy, operation, and environmental advantages. This is particularly benefit for business and industry that rely on electrical power for their operation, helping them save money, increase equipment reliability, and reduce their environmental impact.
Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Nama saya Muhammad Nur Ami bin Ahmad. Hari ini saya nak tunjukkan macam mana power factor regulator kita berfungsi. Okey, ni kat depan saya adalah depan tuan-tuan ni adalah power factor regulator. Okey, yang kita dah settingkan dia auto. Lepas tu yang ni adalah kita punya target power factor kita. Ni adalah turutan kita punya step kita, yang mana dia punya nilai semua sama je. So saya masuk satu. Yang ini pula adalah berapa step yang kita nak pakai. Yang ni adalah CK setting kita. Yang ni adalah kita punya time untuk dia masuk, capacitor masuk. Yang ni pula adalah current pada S1 pada CT kita lah. Okey, yang ni pula adalah kita punya load bank. Okey, ni adalah beban jenis inductance. So saya akan onkan kita punya beban dan tuan-tuan akan nampak power factor kita drop lah. Okey. Nampak dia dah drop. Okey, nampak inductance dah menyala. Maknanya dia detect ada beban jenis inductance kat situ. Okey, nampak inductance tu menyala. Okey, so satu step dah masuk kita punya capacitor, second step. Okey, masuk lagi satu step. Okey, dia dah baikkan semula kita punya power factor kita. Okey, ni saya dah matikan saya punya beban. Okey, dia lebih pada capacitor lah. Okey, nampak pada cap tu dia menyala. Okey, so dia matikan. Mati. Okey, power factor kita dah kembali normal.